Okay, here's a lesson on Mathematica. One of the first things that you want to be sure to realize is that you can change the size of the font by clicking down here in the corner. So you can make it real small or you can make it real big depending on what you need for your desktop. I've entered this file before, so anything with double quotes like this is a comment. Anything that ends with a semicolon, it won't print. If you want it to print, you leave the semicolon off. So for example, here's some comments that you can read, and in this input cell over here, they're all together, so when I execute it, everything within this cell will execute at the same time, and it will do what I'm telling it to do. I'm telling it not to print this or this or this, and this bottom statement will be executed. In order to execute this, you have to hit the Enter key. If you're on a desktop computer with a large keyboard, you probably have a numeric keypad. You can press the Enter key on the keypad and it will execute. If you happen to be on a laptop that doesn't have the numeric keypad, you can hold Shift and hit the Enter. It carries your turn from the regular keyboard. So I'm going to hit Enter, and you can see that it does what I told it. It doesn't print anything except that last line. Okay, what I like to do is I like to quit the first thing when I come into a Mathematica file, because it will remember everything that you have done, even if it's in a separate file, until you either close Mathematica and reopen it, or you give a quit command. Now, one of the things that if you notice, if you read the text above, everything that Mathematica knows how to do starts with a capital letter. This time I put a lowercase quit, and if you notice, it didn't do anything, because up here this was the output number 6. If I had quit, it would have been output number 1, but it didn't, and the reason it didn't is because this needs to be an uppercase. All right, so here we go. I'm going to execute the quit properly, and so as soon as you say quit, it quits, baby. Okay, so anyway, Mathematica uses radians as a default, so if you want to use degrees, you have to, you can either do the conversion yourself, but if you use a capital degree, it'll know that the 30 is intended to be degrees. Now, the way it's written here, you could, this is 30 times degree, but if it's obvious to Mathematica that it's 30 times degree, because names can't begin with a number, then it'll realize that you want to multiply. Until you get used to it, you can put in a multiplication for that. And so it took the cosine of 30, and you can determine that by your calculator if you want. Mathematica likes fractions. Most engineers don't. Your accuracy is greater if you use fractions, but if you don't want a fraction, you can just give it this 2 division signs with an N, meaning numerical, and it'll come back with a number. Okay, you can name things. When you name things, you use a single equal sign. So here I'm trying to name a cosine equal to 3. If you did something, if it allowed you to do something like this, it would mess up the cosine. You wouldn't be able to calculate the cosine properly. I didn't realize that they protected it, but even if you try to mess it up like this, it comes back and tells you can't do it. All right. Okay, so here is a set of equations. Equations use 2 equal signs. Names use 1 equal sign. That's something that you need to be careful of. Make sure that you get, always remember that. It's hard to see sometimes, but these guys right here, that's 2 equal signs. You just type 2 equals right back to back. Don't put equal space equal. Just okay. Now all sets fall within these 2 curly braces like this. So this is a set of equations. You can have as many in the set as you need. 10 equation, 20 equation, doesn't make any difference. Each one is separated by a comma. And this spacing doesn't matter. You can put in any spacing. So Fred is what I'm calling this set of equations. So whenever I want to use the equations, I just use the word Fred because I've renamed it. Obviously, you would probably want to name it something that makes sense. So I execute that. It tells me this is what it thinks I said. X plus y is 3, and 2x plus y is 4. And you might check that and just make sure that it's doing it. The way you solve them is you just say you want to solve the set of equations. You have to tell it what to solve for, x and y. Now, when it comes back with the solution, it uses these little arrow things. It's telling you that x is 1 and y is 2. So that's how it indicates it won't say x is or x equals. It gives you these little arrows. Okay, so here's another one. One of the reasons that you have to tell it what to solve for is your equations can be complicated. They can have more than x and y as symbols. So here's the same set of equations, very similar, but I'm using 3 symbols rather than 2. So I hit execute. Oops, I've got an error. The error is, if you notice here, this is 1 equal sign. Equations have to have 2 equals. So if you leave one off, quite oftentimes you'll get these kinds of error messages. Okay, so I forgot the double, so I'm just going to retype it here. And so there's my equations, all right, and then I'm going to solve it. So here I'm just demonstrating. I'm going to, you only have 2 equations, so you can only solve for 2 unknowns at the most. Your equations could be dependent, which case you can't solve for 2. But anyway, you have to tell it which 2. And so here I'm just demonstrating that, the first one will solve for x and y, the next one x and z, the next one y and z. So in the first time you solve for x and y, well, your answer is going to have z in it. If you solve for x and z, your answer is going to have y. If you're going to solve for x or y and z, your solution is going to have x, because you can only solve 2 equations for 2 unknowns. Okay, let's take some derivatives. All right, so here f is named. It's the name of something. This is my function, and it's t plus t squared. I'm going to find the first derivative of it. That comes out fine. Second derivative, all you have to do, if you notice, you just add on an extra comma t. Third derivative would be another comma t, and you can verify that by hand. Here's another one. Okay, so now I'm trying to have the function equals to x, and x is going to be a function of time. So you try to find the derivative with respect to time. It gets 0, and the reason is because Mathematica thinks that x is a constant. That's the default thing. So I want to tell it, no, x is a function of time. So here's how you tell it that x is a function of time, right here. And then when you take the derivative, we'll see what we get now. So now you get these x ticks. These are the way it represents x dot. And so this would be, it's used the chain rule. The reason is because I told it very specifically x was a function of time. One of the mistakes that students will make is they'll put the bracket t on one of the x's, but not on all of the x's, and that'll give you some errors. If you want to take the second derivative using the chain rule, right, it knows how to do it. It gives you x ticks on where it needs to go. If you want third derivative, looks like this. I don't know why you'd ever take a third derivative, but this is your x triple tick. Okay, integrals. All right, so here's your function. It's a function of time. If you want the indefinite integral, you just say integrate. You say your function with respect to what variable you're integrating. Definite integrals, you can give the variable name that you're integrating, and then you give the lower and upper limit. I don't like to use definite integrals, but you can. We're going to integrate this thing with t, right? And the problem is that it thinks x is a constant. So a constant, integrating a constant times t, you get a constant t, and then x squared is a constant. So it's kind of silly, but all right. So now what you want to do is you want to integrate, and you say, okay, the x is a function of time, okay, and integrate that one. Of course, it can't do it because it really doesn't know what x of t is. Okay, so suppose you want to plug numbers into some ugly function. So I'm just creating some ugly function here. I'm going to call it ugly. And so there you go. There's your ugly function. You just want to plug in 1 for x. And so the way you do it is you use this, divide in a period, and then you use the arrow function, right? So x is temporarily 1. So you're going to set x equal to 1. You're going to shove it into ugly. And if you do, you get this result here. Right, so the x is 1 degree, right? It'd probably be easier if you made it a number, just so you can see where the x 1. All right, so you see the x is gone, it's a number, but you have a y left over. Okay, all right, so let's see, it temporarily sets the x equal to 2. So now you want to plug in a set of things. So x is 1, y is 2, and so sets are always in between these brackets, right? So this means substitute in, and then the bracket means a set. So when you execute that, it plugs them both in. And you can show that as a number. So you just add this / n like before, and it gives you to it as a number. So you can see that all the x's and the y's are gone. Okay. If you want everything as a number, all you have to do is make one of your numbers with a decimal point. Either one of them would work, or all of them. It doesn't make any difference. But if any one number has a decimal point, it says, oh, you want me to give it to you as a decimal. So it does. Okay. If you want to set x equal to 1 and y equal to 2 forever, from here on, every time you execute something, x and y is equal to 1, you can do it like this. And then you don't have to use that substitution. I like the substitution because sometimes you want to plug in different values of x and y and whatnot. Okay, if you want to, like you've defined, y is 2 up there, so whenever you type y, it's going to say 2. Suppose you don't want that, then you can tell it to forget it. So you can say forget the y, and now it doesn't know what y is. So you can say what's y, and it says it's just y. I have no idea. Okay, so that's the first lesson on Mathematica. Hopefully that gives you a little bit of a method of starting with it.